So once we have designed our insole in the CAT software, the CAM part of the system takes over. The CAM part meaning computer aided manufacture. And basically what happens here is that the software will create what is known as a toolpath, and it will create a file consisting of what is known as G-code. G-code is a series of instructions that will be understood by the milling machine, and the G-code will describe so to speak, it will describe the tool path where the tool needs to travel from one place to the other in order to cut the necessary shape in the insole. The milling machines that are used to manufacture the insoles come in various shapes and sizes. They can be small milling machines, they can be industrial milling machines. So this is a typical milling machine. Here we see an industrial milling machine which can be used in large labs. And basically what the milling machine will do is they will cut off, they will subtract the material from the blank in order to produce a shape that is compatible with the shape that we have designed within our software. Material for making orthoses can vary using different shore densities. As we said, shore A is a measure of density or hardness of the materials. In this case, we are seeing a dual density material, and even this is a dual density material, and normally we have a higher density material in the back and a lower density material in the front. We can also have single density materials or even triple density materials, which these densities will vary and become softer. The material will become softer the more forward we move in the blank. This type of manufacture is called subtractive manufacturing, as opposed to additive manufacturing. And additive manufacturing we refer to 3D printing, which is an exciting type of CAD/CAM manufacturing system that has a great potential even in our clinics. But once we have designed our insole and we have put this in the milling machine, this can be repeatedly manufactured in a few moments and utilizing very safe measures that cannot and should not be harmful to the operator. And I think that is a very important aspect of it all, because even for our young podiatrists who will have a career of many years, the risks of causing lung damage with all these inhaled dust is quite extensive. So we have talked about CAD/CAM systems, and we have seen examples using custom design systems. Normally a podiatrist would revert to buying a system that is customized for making insoles or orthoses. However, one has to bear in mind that anything can be designed and manufactured using these systems. So any system that, even though it is made for orthosis, utilizes as an engine, as a software, a CAD and a CAM system. So basically we have published an article on Foot and Ankle Online Journal which shows that CAD/CAM systems can be used for the design and manufacture of foot orthoses, even though they are not made specifically for making foot orthoses. What do I mean by this? We can use generic, what we can call as generic CAD/CAM systems to make our own CAD/CAM system what we want. And in this article we show what the whole process involves, and we show that using software, and nowadays even open source software that can be used to design our orthosis and to manufacture our orthosis, we can actually save a lot of money. For anyone wishing to indulge in such a project, in this article we talk extensively how these software and these systems can be implemented in order to create our own CAD/CAM systems. So for the purpose of this designing this insole, as you will recall, we have marked the location of the ulcer, which, as we said, is slightly distal to the first MPJ. Since we had to cover the area in order not to get an infection, it was important to mark the exact location of the ulcer. We start off this design by choosing an appropriate insole for an appropriate design of insole for this patient, and in this case we're going to use a diabetes insole, her size, and diabetes insoles are a bit bigger, a bit wider, and will allow us to fit into wide fitting shoes, which is what is really needed by this patient. Once we have designed and placed the insole at the appropriate place, we need to set the forefoot area. In this case we're going to do it at a thickness of 3.5 millimeters. Once this is set, we will smoothen the area various times in order to get a smooth base of insole that we can work on. As you can see, with a few clicks I already have a basic design of an insole. Next step is to produce a basic medial longitudinal arch support, which is necessary since the insole was extremely flat. So the next step is to produce what is known as a heel dish in this software. A heel dish allows us to basically produce an area around the posterior aspect of the heel, as one can see, and around the lateral and medial border, in order to be able to cup the rear foot. However, this needs to be modified slightly until we have the right profile for the dish, and this profile will be acceptable for our design. And basically it is what I am doing here is like grinding. It's as if I have the orthotic, which I am grinding off this part to make it all smooth and acceptable for our design. As one can see, it is slowly taking shape, and at the end of the day, however, I am not at risk of inhaling any dust, and the insole can be done virtually and until I get the design that I want. So we can see that the insole is being designed until we get an acceptable type of rear foot. Now, in order to offload this area here of the ulcer, we are going to draw a custom type of pad. It is basically what we call a single wing plantar cover, and to do this I use a device called as freeform element, and this freeform element will allow me to basically design any type of padding material that I can, any type of padding design. So as we can see, the shape of the single wing plantar cover, which is going to leave our area of interest, which is the ulcer, which is approximately here. And in order also to increase the effect of the padding there, we are going to do what is known as a punctual correction. Basically, we're going to produce a small indentation in the insole, which I am placing exactly in the area of interest. Okay, so as we can see, the area where there is the ulcer is now indented. Also, I made sure, because if you recall, the patient had quite wide fitting shoes and they were quite loose, so the foot was sliding forward. I made quite sure that the area in front of the ulcer was also covered by this indentation. In the final part of the process, what I'm going to do, considering that the patient has such severely pronated feet, but at the same time her feet are quite rigid, I'm going to insert a small amount of medial posting for the rear foot, or for the foot actually. So to do this, I just use a function called torsion here, and this torsion, with this torsion function, we have these lines. So in this red line shows us where our correction ends, and this anterior line shows us where it begins, and this vertical line, as you can see, there is a blue representation on our 3D model here. This will show us the area where the wedge or the posting will begin. So this here is the lowest part of the post. Okay, so the post is going to be behind the metatarsophalangeal joint areas up to the heel. And here we can determine the amount of posting. And just to exaggerate a bit here, there is a 3-degree post. I can, like, if I want to put in 9 degrees, you can see the effect it has on the rear foot aspect of the insole. So let's put it back down to 3, and you can see the difference in the posting. Okay, to conclude, I think we need to smoothen this a bit again. So this will be the shape of our finished insole. I need to choose a suitable material from which it is going to be milled, and I'm going to use a dual density material, which is normally lower density in the front and higher density at the back. And this is the representation of the insole in our blank, in our milling machine. Oops. So I need to position it in such a way that the rear part will be in the high density part of the blank, and the forward part is the low density part. I can save this and then send it to our milling machine. So just to recap what the whole process involves, as you can see, it only took me a few minutes to design this insole. First of all, I chose the appropriate insole, type of insole, which I wanted to apply to this patient. Then using 4-foot adaptation, and let me remove this, I decided on the cutoff area where the 4-foot extension is going to start, and basically the thickness of the 4-foot extension, which we set at 3.5 millimeter. And then we smoothed this to have an insole. We produced a medial longitudinal arch and the heel dish around this area, around the heel. And then I designed a single winged plantar cover, a punctual correction to offload together. These two will offload hopefully will offload the area of the ulcer. Torsion, we applied a small 3 degrees medial post, smoothed it again, and chose the appropriate blank from which to cut or mill our insole. Next stage will be to design the other insole and basically mill it, send it to the milling machine. For the other foot, we will be designing another insole, however this time without having to offload an ulcer, obviously, because there is no ulcer. Again, we will choose an appropriate insole from our library, and like the other time we used a diabetes female size 39, which we can appropriately position onto the foot there. And following that, again we will do the 4-foot extension, 3.5 millimeter. In this case, as you can see now, the process will be much easier than the other one, and it will take me just a few minutes to design the appropriate insole for this patient. Again, a medial longitudinal arch support. It will be placed in the appropriate. The software techniques obviously will change from one software to the other, and each particular software will have its own requirements. We are using Paramed software here, and this Paramed software requires that we do a medial longitudinal arch support so that we can control the height of the arch if we wish to. Other software may work differently, but the principles more or less may be the same. So I will continue designing this. Again, a heel dish would be really important here. So with the heel dish finished, again, now we can see the smooth appearance of the insole. Okay, so next thing I will do is I will insert a small correction, a small medial longitudinal a small medial wedge or post on the hind foot, around the starting from proximal to the metatarsophalangeal joints back to the midfoot, in order to try to limit as much as possible the pronation that this patient exhibits. And last thing is I will also choose a material. We're using a double density material again, so it will be slightly softer on the this forefoot. I am positioning the insole exactly where I want it, as you can see on the blank, and only thing I need to do now is I need to save it and send it for milling. So left insole